computer. The distress flare, I'm pretty sure you guys know what distress flare is. It's just some kind of shiny stuffs. You just, shoot it up so that other people in the sea can see, okay, there is a ship in danger. Let's go for rescuing it. Okay. A distress flare may be launched from a boat to signal for help. Flare was launched from a stationary boat at an angle 30 degree to the horizontal. Okay, so at an angle 30 degree to the horizontal. The flare was launched to the right from the launch position marked X. So here it is. Complete the diagram to show the path taken by the flare. So you have to just draw a parabola over here. Fine. A part is easy, right, guys? A part you guys understood, no? Guys, understood, right?
Yes.
Yes.
Oh, sorry. So now, the maximum height of the flare above the launch position was 42 meters. Okay. Show that the flare was launch speed of 60 meters per second. So what they said is, this is the height of the flare. So the height from where the flare was shot, and it went a maximum height of 42 meters. So remember what I say. Here your final velocity is 0 and your initial velocity will be u sine 30. So S is known to me. So V square is equal to U square plus 2AS. Everybody understood this?
Yeah.
So what is the final velocity? 0. What is the initial velocity? U sine 30. At what speed was it thrown? We don't know. Do we know at what speed it was thrown? Flare was launched. Show that it was launched. Ah, okay. Fine. U sine 30 whole square. Okay. Plus 2 into minus 9.81 into 42 meters. Do this in your calculator. Bring them on this side. Becomes positive. So 2 into minus 9.81 into 42. Okay, bring it on the other side. Root of the answer divided by sine 30. 824.04. So 824.04 divided by sine 30. Sorry, root of it, then divide by sine 30 will give you u. Is that understood? Root of the answer divided by sine 30. So I'm getting 57.4 meter per second, which is close to this thing. But remember, why did I use this? Because the time taken to go from here to here is exactly the time taken to go from here to here. This part everybody knows, na? So that's why I use this method. Let this be the initial velocity. Let's do the final velocity. I know the vertical distance maximum. Then I use v square is equal to u square plus 2as. Everybody understood this, right? Online?
Yes.
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 Now let's go to the next one. 4 marks question. Again, the flare was visible from a maximum distance of 8 kilometers. My God, from 8 kilometers they saw it. A rescue boat was 8.2 kilometers from the boat in distress. Determine whether the flare traveled a sufficient distance to be visible from the rescue boat. You should assume that the flare was launched in the direction of the rescue boat. Fine. So flare was visible from this thing. A rescue boat was 8.2 kilometers from the distress. Okay, let's see how much horizontal distance did they travel. I want to know this. For this, I need to know how long was it in air. Okay, I need to know how long was it in air. And Is there anything I'm missing over here? I'm not 30-degree stationary, complete the tab, blah, 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 blah. The flare was visible from a maximum distance of 8 kilometers. A rescue boat was 8.2 kilometers from the boat in distress. 8.2 kilometers. Okay. So can we see how much time did this guy take, by the way? I know the horizontal distance. Let me pause the recording and let me think about this. Because so let's try that old trick that when it came back to the same position from where it was thrown from. Okay, so your S is 0. Let's take S0 and check it. Okay, S0 the try query that how long was it in air? Let's find that. Or we can use even V is equal to U plus 80 as well. Yeah, we can use V is equal to U plus 80 because I know V is equal to U plus 80 over here. I know the maximum distance it has traveled. Maximum height, the flare above the launch position is 42 meters. Yes. So let's do V is equal to U plus 80. Like we know that whatever your projectile is, if I know how much time did it take to go from here to here, and if I multiply it by 2, that will give me the time for the whole parabola. That is, everyone knows this, na? Online? Everyone knows this, right? I'll pause the recording. There is a call. That you, if you know how much time does the ball take to go from ground position till the maximum point, and if you multiply that by 2, that will give you the time of the whole parabola.
Oh, yes, yes.
Okay, so that's what I'm going to do here. I'm going to use V is equal to U plus 80. V is 0, U I got is 50. No, U cos theta asta hobe. 57.4 into sine 30. 57.4 into sine 30. 57.4 into sine 30. Okay, minus 9.81 into t. So do this in your calculator. 57.4 into sine 30 divide by 9.81. So 2.92 seconds. Just double check. I have an issue with my calculator. Is it 2.92? Double check karo dekho, there is 2.92 na?
Yes.
Yes.
Yeah.
Okay. So এটাকে multiply by 2 karo. How much will that be? Sorry. 2.92 multiplied by 2. 5.84.
Yes.
Understood? So 5.84 second. Now, how much horizontal distance did he travel? I want to know. So what was the speed? 57.4 cos 30. I need to know how much horizontal distance did he travel, because that will tell me whether that guy saw the warning or not. Yes, from height you can see, but he was 8.2 kilometers, more than people could see. But if this guy can cover that 200 meters, if the flare can cover that 200 meters, you know that the rescuer can also see them. Let's see whether that is okay or not. So I'm having 57.4 multiplied by cos 30. 57.4 cos 30 S equals to yes into time 5.84 S equals to ut. Okay, so 57.4 multiplied by cos 30 into 5.84. So he has traveled 290 meter. So basically the rescuers were 8.2 kilometer, and you can see it till 8 kilometer. But how much distance did it travel? It traveled 290 kilometer. No, basically it traveled more than these guys can see. Therefore, yes, the rescuer can see the flare. Everyone understood the rescue boats? Because look, if this would have been less than 200 meter, you know that the rescuer will not be able to say this thing, see them. But now it is more than 200 meter. That means the rescuer will be able to see, because the minimum distance is 8 kilometer. Watching distance is 8 kilometer, but these rescues are 200 meter more than that. But this guy already covered 290 meter with the help of the flare. So they are able to see it. I hope you guys understood this common sense thing, concept. Everyone understood this?
Yes.
Online?
Yeah.
Everyone. Okay, I'll pause